여러분 안녕하세요. 제 이름은 북극거입니다. Hello everyone, it's me Arctic Bear. Welcome back to my channel. Um, my apologies first off, straight from the get-go. My apologies. I'm normally supposed to show you a travel video today, but unfortunately that didn't happen because I've actually gotten into an altercation earlier today, and I don't want to get into detail about it. Let's just say I'm not gonna go back from time. Okay, I'm not. I'm just gonna do this for today. I'm sorry. It just didn't turn out the way I wanted to. All right, it was bad. Let's just say it was a bad time. It was a bad day today. Um, it's a little late right now. It is 12:43, so my apologies if it's really late, but I'm just trying to get my bearings together. So today we're actually gonna do a little something different. We're gonna talk about the heart. Now, mind you, I'm actually a bio major. When I went to William Peace University, which, by the way, amazing school, I actually I'm actually one of the top 10 for biology. I was on the top of my game in terms of biology, right? I did very well in when I was a college student. So, although I'm not a doctor, I'm not gonna lie, I'm not a doctor, I'm not a nurse, I'm not a PA. I'm just someone who's always fascinated in working with the human body. As a matter of fact, human anatomy and physiology was one of the best courses I ever took, and I absolutely enjoyed learning specifically about the human heart. And that's what we're going to be talking about today. Okay. Um. So, a little brief summary of the human heart and what you should know, right? The human heart acts like its own vessel, like its own muscle, so to speak. Not a vessel, but muscle. It's the only organ, so to speak, in the human body that actually requires electrical impulses, meaning that it does not really need a hormones, or it doesn't really need a protein to activate the heart. Basically, the brain telling the heart, "Hey, pump some blood." The heart does it on its own. The heart's like, "Hey, I'm on my own. I do what I want." Right? The heart is one of the single most important muscle in the human body. It is also the one of the largest muscles in the human body, right? Surprisingly enough, there's actually a muscle bigger than this, and or although this is an organ, but I like to see it more as a muscle because it kind of acts like one. But there's a muscle that's bigger than this. It's called the gluteus maximus. If you don't know what it is, it's the buttocks. So, fun fact for you. Anyways, back to the human heart. So today we're gonna talk just about the blood flow. We're just gonna go through the blood flow, all right? We're not gonna go into too much detail of the heart, okay? Um, you're probably gonna see other videos out there that are more into detail with this than I am. But this is just more the basic, gives you a rundown of what to expect. So this is a pretty good realistic detail of the heart, huh? You know, I guess. Sure, we'll take it. So we'll start with something called the superior vena cava and the inferior vena cava. What these are veins, okay? They're actually the largest veins in the human body. What they'll do is they'll take in blood, carbonated blood. That's carbonated. Oh my god. Blood the blood that carries carbon dioxide. Okay, they're gonna take it in from the inferior and the superior vena cava. This blood is unclean. This is the blood you don't want to have in your body. We want to recycle this blood basically, because what you want to do is you want to trade in that CO2 for oxygen. And which organ does that? Lungs. Okay, that's why you don't smoke. Do not smoke. Don't smoke, because trust me, you're gonna regret it. I don't smoke. I've never smoked. All right. Don't do it. It's not fun. It's no Kinder Bueno, okay? So, we're going to go ahead and start here. Veins are fairly weak, actually, alright? They're fairly weak. They are unidirectional, meaning they're only one direction. You don't want them going backwards. You absolutely do not want veins going backwards, okay? You want blood going forward, alright? Arteries is exceptional because they do have oxygen, so they can replenish all the muscles in your body as needed. These guys, they don't. Okay, they don't do anything. Their veins, they're weak, and they're weak for a reason. All right, they're not supposed to have they don't have the appropriate amount of oxygen that they need for energy. All right, for ATP, so to speak. So By the way, ATP, adenosine triphosphate, the inactive form of energy. You have to break off a phosphate group in order to make that ADP, adenosine diphosphate, make it active, right? We'll get to that in another time. So as blood enters the superior and inferior vena cava, it's going to pool into this region called the right atrium. It's a chamber. It's the first chamber of the heart. And you'll notice that there's these two pits. That's where it comes in. This is called the right auricle. And the right auricle, what it does, it's basically expands this right atrium and tells it, hey, let's increase surface area, but so that therefore we can allow as much blood to pool in as possible. Okay, when that happens, it triggers a sensory neuron that actually orders this part of the valve called the tricuspid. All right, and it tells that valve, hey, let's go ahead and open up the valve, the gateway to the right ventricle, which is the other chamber, the much bigger chamber, actually the biggest chamber in the heart. And so when that happens, and again, electrical stimuli. Why? Because the heart is the only organ that undergoes electrical contractions. So as the stimuli is activated, this tricuspid basically goes like, okay, great, let me open up the gate so that therefore we can pull in this blood from here to the right ventricle. All right, mind you, again, unidirectional, does not go backwards. You do not want this blood pulling back up to the right atrium. If that happens, you have a problem. Okay, you do. And if that ever, there is a form of I don't think it's a disease. There is something that does cause this to happen, and if that does happen, you absolutely need to go see a cardiologist. Okay, because listen, your heart needs to be almost perfect. Okay, you don't want to have a bad heart. Let's just put it at that. So as blood pools into the right ventricle, it starts to pool up. All right, and you might think, okay, so this chamber here is small, this one's big. What happens if all the blood here is spent from here? Well, then it's going to pull in more blood. All right, blood pools in here, and it'll just pull in blood back into here, into the right ventricle, until eventually it fills up. There's a certain point where this, again, surface tension kicks in, electrical stimuli gets activated. Now it's basically telling the heart, okay, I gotta eject this guy right out. All right, so it's time to push that blood right out. Okay, that's why you heard a bum bum, the heartbeat. The first beat pushes this blood right out to the lungs. All right, and it's going to push it right out, called the pulmon. It's going to push it actually to what we call the, let me see if I can find it here. Okay, well, oh, it's right here. Pulmonary trunk. Oh my god, how did I not see this? Pulmonary trunk carries blood to lungs. So this is where it does, all right? And this is actually, it's unique because the pulmonary trunk is where the blood gets ejected from the heart, again, to the lungs. And as the blood travels to the lungs, it goes inside and then it transfers that CO2 to oxygen. The blood does that. As it's doing so, this is the only time, mind you, this is the only time it does this. The artery, the pulmonary artery is the only artery that's going to carry CO2. And it takes that to the lungs. Okay, doesn't say it, but trust me, the pulmonary artery is the only artery in the human body that's going to transfer that CO2 to the lungs. No other artery will ever do this, ever. Why does it do that? Ask God. He created us. All right. So and it goes to the lungs, filters CO2 to oxygen, and now it comes out called a pulmonary vein. Crazy that we call it a vein, even though vein's supposed to carry CO2. Again, ask God. And then it goes in to the pulmonary vein after blood has been cleaned out into oxygen, and it's going to dump it right into the pulmonary vein, back inside to a left, where is it? Left atrium, right here. So the left atrium is where it pulls it in, right? Much smaller than the right atrium, okay? And as it goes in, it's the same thing. Surface tension kicks in. You want to go ahead and expand that space a little bit more from the left auricle, and it's going to cause another electrical stimuli to activate, and tells this bicuspid valve, or known as the mitral valve, telling it, hey, open up those gates. Let's go ahead and pull in blood from the left atrium down to the left ventricle. all that oxygen in the blood comes in, pulls in. It's the exact same thing as the right ventricle. Increase the surface tension. Electrical stimuli gets activated. Tells the heart, okay, we got blood pooling in here now. Let's pull that blood right out to the aorta, and that's where it comes out. All right, that's the second bump bump. Okay, so the bump 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 bump. You've heard a heartbeat, bump 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 bump. That's the second one. It pushes that heart right out. That blood pulls right out into the aorta, which is the largest artery in your body, and then goes out. Other than the aorta, the first organ in the human body that actually gets fed with this fresh CO2, oh my god, this fresh oxygenated blood is actually your heart. Right? It's gonna go something known as the coronary artery. Your coronary artery is where it feeds the blood, and it feeds the heart with blood, with oxygenated blood, right? I mean, your heart kind of deserves that. Your heart's the one pushing out all that blood for you, delivering it to the rest of your body. Don't you think the heart gets the first pick, gets the first say? They do. And so it's that's where the aorta comes in. This is the largest artery in the human body. These are the largest veins in the human body. And the aorta, you need to have a lot of pressure. You need to have a lot of electrical stimuli to kick in, because you want that blood, again, traveling right through the aorta and filling up as much of these arteries as possible. Okay, so you have to really thank your heart a lot. All right, your heart's doing a lot of hard work for you, like an insane amount of hard work, right? And so that's why I have a lot of appreciation for the heart. That's why I have a lot of appreciation for the human body, right? So that's what this is. That's what we call the blood flow to the heart. So again, it goes to the superior inferior vena cava, carbon dioxide, blood that has carbon dioxide. Superior inferior vena cava pulls into the right atrium. Basically tells the tricuspid valve, hey, open up. The valve's open. Blood pulls into the right ventricle from the right atrium, and then afterwards, the blood then shoots out from the ventricle to the pulmonary artery, goes straight to the lungs, gets transferred from CO2 to oxygen, pulls it right back into the pulmonary vein, pulls it into the left atrium, and then basically tells the bicuspid valve or the mitral valve, hey, open up. Same thing. Blood pulls into the left ventricle, and eventually the same idea comes into play. Surface tension kicks in, tells that heart, okay, kick this. This blood is good to go. It's like going through a checkpoint. Let this blood go to go, and then boom, it goes right out to the aorta. Now, there is a valve here, and the valve, it sits right here. This really does act like the security gateway. It's called the aortic valve. It's literally just called the aortic valve, the semi-aortic valve. And the reason why it's called that is because there are these really small hair-like valves. They're like cilia-like valves. And what they'll do is they are also unidirectional, but they basically, as blood gets pulled out, it's like a checkpoint. So it's going to determine if that blood really is good to go. All right, and it acts like the last barrier. So as blood pulls out, it won't pull back in. Right? Again, you don't want blood pulling back into the heart. You want that blood coming out. You want it going unidirectional no matter what. Okay, because you need that blood going out to the body. Right? Your body needs oxygen. It's desperate for it every single heartbeat. So that's the heart structure for today. That is the what we call the blood flow to the heart. Again, please do not check out the song. Please, I'm not gonna play it. I still remember that song in my head, okay, and it helped me. It did, in the cringiest way possible. So, nonetheless, though, thank you for watching this channel. I hope you enjoyed hearing me talk about the blood to the heart. Again, your heart is an electrical impulse, right? This is what we call an involuntary contraction. What that means, you don't have to think about it. Your heart pumps on its own. So you don't need to physically move your body to get your heart running. Your heart will do it on its own. So, wonderful 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 part of the human body. Thank you for watching my channel once again, or watching my channel. Wow, watching my video, sure, yeah, either one. And I will see you in the next video. Once again, sorry about what happened, about not showing a travel video. I really just don't want to talk about it. It was bad. It was bad. I got into an altercation. I don't want to talk about it. So, nonetheless, though, truly thank you, and I'll see you in the next one. Bye. 안녕 갔습니다. Or 안녕 가세요.